Answer the questions based on the following situation. For a population of 4,000 students taking the SAT math exam, the scores on the exam have an approximately normal distribution with center mu equals 610, standard deviation sigma 60. So all these questions here, 32 through 35, notice are all going to be about this situation, normal distribution. So what do you do when you see the words normal distribution? The answer is you go to this thing, the normal curve distribution. So this is what you want to have on your notes for exam 5, is this normal curve. Take a picture of it, draw it, somehow put it in your notes for exam number 5. These percentages are always the same from one normal distribution to the next. A bell curve, normal distribution, all those names fit. What changes from example to example is the specific numbers at the bottom. Let me show you. So we go here and we go center, mu is 610. So we go put that in the center. Right here, 610, right in the center middle. Okay, standard deviation is 60. That's how far from line to line, jump to jump, 60. So that means this is going to go from there to there. See how here it says standard deviations? That means from line to line, the jump, this is going to go up 60. So this will be 670. I just added 60. And then I'm going to go up 60 again. So what's that going to be? 730. Just use your calculator. I just took 670 and I added 60. Let's do it again. Add another 60. That'll be 790. So so far, I've just started in the middle with 610 because they told me that was in the middle. Right here, they tell you the middle, the center. And then they tell you the jump amount from line to line. Start at 610 in the middle, go up by 60 for each line. So I started at 610 in the middle, I add 60, add 60, add 60. Now, the other way, I'm going to subtract 60. So go this way, go down 60. So what's that going to be? 550. Just use your calculator. Subtract 60 again. I think that'll be 490. And subtract 60 one more time. And that'll put us at 430. So we're finding what these different line amounts are. So again, it's all about starting in the center, 610, and then adding 60 to the right for each line and subtracting 60 to the left for each line. Now that we have that in place, and that's how you'll always do these problems, the percentages are always the same for every normal curve. That's what they mean normally distributed, meaning these percentages hold true. This is the normal way things are spread out. And then you just take the average they give you, the middle, and the standard deviations. This goes in the middle, and this is the jump from line to line. You put it all in there, and now let's answer their questions. Here's the first one. They say, how many students scored between 490 and 730? So 490 is right here, and 730 is right here. Well, look at this. 95%, huh? Or you could just add up this percentage, this percentage, this percentage, and this percentage, which are all the ones between those two lines, and you would get 95%, same thing. So I'm going to go back to it now and take my 95% with me. Say, well, 95% of all the students. See how I got that? I just looked down here between 490 and 730. Which is the numbers they told me, 490, 730. I went to 490 and 730. Between the two lines, 95%. All right, let's go back. Now, that's not, you don't see that answer yet. I've got to make it to a decimal. Of is times, 0.95 times all students. How many total students? 4,000. So it's 95% of all the students, which means 0.95 times of is always times 4,000. 95% of the 4,000 students, that's 3,800 students. So there's our answer. Great, let's go to the next part. Approximately how many students scored below 730? So let's go find 730. Here's 730 right here. So how many students scored, whoops, it's in the curve. I shouldn't have done that. Let me back that up a little bit. How many students scored in all this part of the curve below 730? Well, there's two ways you can do this. You can add up 13.5, 34, 34, 13.5, 2.35, and 0.15. Those are all below. Or you could just add up the two that are above and subtract from 100%. That would be easier. So let's do that. So how did I know to go left? They said below. Below means to the left. So let me just do it the long way. Maybe make more sense for you. So I'm just going to add up all these numbers to the left. So if you take those numbers out, it's going to be 13.5%, right? Making that right? Plus 34 plus 34 plus 13.5. Plus 2.35%. Plus 0.15%. I got them all, didn't I? Right? Yeah, it looks like I got all the ones to the left. Below 730. To the left, right? All these numbers are below 730. So I have to add up all the percentages in the curve to the left of 730, below 730. So if you add all those up, let me see, what are you going to get? I think you're going to get 97.5%. And now you know what we need to do with this. We need to make this 0.975, right? You got to change it into a decimal, move this back 2 places, times the total number of students, 4,000 students, equals 0.975 times 4,000 is 3,900 students. There's our answer. So we added up all the percentages that were to the left of 730 on our curve. We found 730, added up all the percentages to the left, and that came out 97.5%. Change that to decimal, move the decimal back 2 places, times 4,000, because it's that percentage of all the students of the 4,000 times the 4,000 students is 3,900 students. Almost all of the 4,000 students have, a SAT score below 730. Now, let's go on to the third part, or to the question 34. So now it says, so this one will be a little more tricky. Track with this one. This is important. Approximately how many students scored more than 570? More than 570. Let's go find 570. Ooh, I don't see 570. I see 550. I see 610. 570 should be about right there, shouldn't it? It's not there. You know, the last problem we did was 730. It was right there. And before that, it was 490 and 730. They were there, but this time I don't see it. I don't see 570. And look, it should be a little bit to the left of the middle, shouldn't it? Should be about right there. 570. What's up with that? What's up? Well, this is the trick you need to know. Remember that we had 2 special formulas. We had Q1 and Q3. Whenever they give you some number that's not in your chart, it's got to be one of those. Remember this, so you want to have these on your note card, on your notes for the exam. The Q1 formula was mu minus 0.675 sigma. And the Q3 formula was mu plus 0.675 sigma. So this, I hope I'm not confusing with this little symbol at the back here. This is it's not a 0, it's a sigma. So it's this thing. So let's try it out. Let's bring this down right there. Let's find out what Q1 is. In mu, they gave us mu right here. 610 right there. They gave us that mu, and there's sigma. So that means 610 minus 0.675 times sigma, which is 60. And on my calculator, when you do that, you get 569.5, which rounds to be 570, which is what we had here. So what? What's my answer? Well, the whole point of that is just to show you that when they give you 570, they're really giving you Q1. Okay, so what, you might say? So they're giving me Q1. Well, that tells us what to do, if you know what Q1 is. What is Q1? That means right here, at 570, that's the Q1 mark. I tested it with our little Q1 formula. Said, I bet that 570 is Q1. I plugged in mu minus 0.675 sigma, our formula for Q1, rounded it off. Sure enough, 570 is our Q1. Okay, again, so what? That means that's the end of the first quarter. Remember what the Q1 means end of the first quarter. So you tell me if you're watching a football game or basketball game, and I say, my wife calls from the other room and says, hey, honey, how's the game going? Where you at? I said, we're at the end of the first quarter. What does that mean? How much of the game is over? 25%, right? First quarter's over. That means this way, that means all these percentages must be 25%, because 25% come before the end of the first quarter. So what part got below to the left of 570? 25%, because 570 is the Q1. He's the end of the first quarter. So that's 25% came before him, below him. Below is to the left. Didn't they say below? Oh, no, I better be careful, huh? More than. Better read the words. More than. So what part are more than 570? More than Q1. So what if my wife asked, hey, honey, how much of the game is left to go? And I'm at Q1. I'm at the end of the first quarter. What part is left to go? 75% more to come. And they asked how much more, right? If you're at the end of the first quarter, there's 25% that way, and there is 75% that way, more, higher. So what percentage are higher than 570? What percentage of all the students got higher than a 570 on the SAT? 75% of the students got higher than a 570, because that's the Q1 mark. That's into the first quarter. It's where the bottom 25% sits. So 75% did more than that. So then we can now answer this question. So I'm still trying to answer 34 here. So the answer to 34 is that 75, so bring this down here, 75% of the 4,000 students scored more than 570. So that's 0.75 times 4,000, which is 3,000. So 3,000 students must have scored more than 570, because that's the end of the first quarter, 75% above it. All right, finally, number 35. 35 says the third quartile of the scores is approximately, what's Q3? Well, we have the Q3 formula just waiting for us right there. So what's the Q3? Q3 is mu. Remember what mu was? Well, it's right here. Mu is 610 plus 0.675 sigma. What's sigma? 60. So Q3, use your calculator. I'm doing mine. and I'm getting 650.5. Now, just grab the 650. Don't worry about the rounding there. 650, 651, whatever. See, it says the word approximately. So that means anything that would round one way or the other. It doesn't have to be exact. That's the whole point of the word approximately. It's not exact. It's approximately. That's approximately 650 or 651. I would take either answer. Both are good. If they have 650, grab it. Don't grab none of the above. It's approximately 650. So there it is. So it all comes from this normal curve. You want to have that normal curve before I did all the drawing all over it. Have that normal curve right on your chart. Would it help if I put another picture of it here? Let me do that for you. There it is. Make it a little bigger. So have that normal curve in your notes. And not only have that, also have the formula for, for Q1, which is mu minus 0.675 sigma. And Q1 hits about right here, but 25% below it. And Q3, the third quartile, which is same thing with just a plus, 0.675 sigma. So I have the normal curve and the formula for Q1 and Q3 in your notes. And Q3 is about right there. Into the first quarter, into the third quarter. And there's the work for that problem, and there's the answers. There we go.